Hello, my name is Salvador Sérgio Agatti, and today I'm going to present you the paper entitled Development and Evaluation of a PCB's Manual Assembly System Using Augmented Reality and Total Quality. Following, you have a summary of what we will talk about. First, we contextualize the problem, then we present the RAMM system architecture and talk about the AR and PR modules. Then we present the questionnaire sent to the experts, and finally, we do the discussion and make the paper's conclusion. Despite the advances in industry, manual assembly is still a presence in manufacturing due to human capacity to support the changes in manufacture variations. But with new improvements in production lines, with a higher precision, reliability and stability of the automated production, human error became more clearly the enemy of product quality. An alternative to pursue the quality industry 4.0, mainly in the manual assembly lines, is using augmented reality. The figure you are seeing is the RAMM system architecture. Number 1 shows the webcam used to grab the image of the printed circuit board the operator is mounting. Its position is, in fact, above the operator's head and doesn't interfere in the workspace. The webcam image is then sent to two models, the Vuforia Augmented Reality model and the OpenCV Pattern Recognition model, as indicated by numbers 2 and 3 in the figure. Number 4 shows the storage model, which records and presents image markers, 3D models, assembly instructions, and production KPIs. Number 5 is the user interface, which combines the output of the AR and PR models and presents the result in the output model, which is, in this application, the monitor the operator already has in his working environment. You are seeing the monitor's output. Number 1 is a tag showing in which step the assembly process the operator is at the moment. Below this information, the operator has detailed instructions on how to mount the component of the PCB, as number 2 shows in the image. Number 3 shows the component name, code or number that must be picked up from the respective bin. Number 4 is a 3D animation of the component being mounted at the moment that rotates in 2 axes, allowing the operator to see all its features like color, polarity, and important markers. Finally, number 5 shows the position indicator arrow that helps the operator on where to place the component in the PCB. The PR model is responsible for validating the PCB assembly. Its function is to validate the step, which a set of components mounted comparing a previously validated image with the current one. As you can see in the image, the PCB must fit into a predefined rectangle area to allow the PR model to work properly. RAMM system evaluation was carried out through an online questionnaire sent to specialist professionals. The questionnaire measured the perception the evaluators had about the developed architecture and the features RAMM has. The final questionnaire consisted of 14 questions divided into objective and subjective questions. The system and its functionalities obtained positive evaluations both by technology professionals and by the assembly professionals. The group of assembly professionals was the one who gave the best scores in numerical evaluations to RAMM. The best evaluated aspects of the system were the graphical indication of the components, the distinction of the components, and the component position on the PCB. In the subjective question about positive issues in advantage, the factor that stood out the most was the use for training. The following best commented 2 factors are directly related to the requirement proposed for this work: the tasks, errors, and in general results, quality. The responses received in the objective questions pointed out the difficulty in recognizing the assembly errors as the main limitation of RAMM. The final overall score of the RAMM evaluation was 80.15 on a scale from 0 to 10, and therefore it can be said that the system was rated as very good. The responses obtained found that RAMM has potential benefits. For example, the RAMM system stands out positively both in the operational aspects raised in the system requirements and in its training potential, which was not an initial objective. The answers raised questions about the system's interface, indicated the addition of features to the architecture, and suggested different ways of applying the system, such as hardware configuration and quality improvement features. The system is ready for initial implementation on the assembly line. Thus, the proposed solution is considered a useful tool to make the PCB assembly process more efficient according to the expectations of the professionals involved. The system is expected to be implemented in the real industrial setup and bring benefits such as error reduction, improvement in product quality, improved control of the assembly line, and help in the assembly process for beginners. Future work includes making the system adaptable to user experience as well as gamifying the experience to sustain high productivity for a longer period. Thank you.